Hello, welcome to CIS 75 Security Plus. This is the recording for module number 8. It'll cover 2 chapters, chapters 9 and 10. Chapter 9 is all about resilience and physical security. There are a number of elements that you can use to build redundancy. You could use a geographic dispersal so that if a disaster happens at a site, it doesn't disable all systems. You're able to continue functioning. You can separate servers and other devices on separate racks to not have a single point of failure. Because let's say the power goes out, if you have different racks with different batteries, your power can be distributed. If a certain servers get knocked out, others can take over and they're not all affected at once. Having multiple network paths is also another way of building that resilience. If one network switch goes down, if a server goes down, there are more than one ways to get information across and keep the network running. Having multiple routers, firewalls, intrusion prevention systems, load balancers, and so on is also another way of building that redundancy on our network. I mentioned batteries, uninterruptible power supplies, having plenty of those to provide power for a short period of time, and generators for longer outages. Dual power supplies on servers ensures that a power outage won't disable a server. Manage power distribution units, provide intelligent power management, and even remote control. These are just some ways of building resiliency, because we know attacks are going to happen. And we also know that natural disasters are going to happen as well. You're going to have some form of outage. So you need to be able to have systems in place to take over when it occurs. When it comes to data, we have things like RAID, where we could have just a bunch of disks and not have any performance or security benefits to our data. We could have RAID 0, which means we will still lose data if one of the disks fails, but it is much more high performance. We could use RAID 1, which is mirroring. What is on one disk will be on the other. It is slower to write because you're writing to 2 drives at once. But if one drive dies, you have an exact copy already. RAID 5 requires a minimum of 3 disks. You lose 33% of each of the drives. And that's if one drive dies, the other 2 or more are able to rebuild. Ideally, RAID 5 is done with 5 drives, but you need a minimum of 3 to do it. RAID 6 is the same as 5, except if 2 drives go down, the array continues. Whereas in RAID 5, if 1 drive dies, the RAID continues. If you lose a second in RAID 5, then we have a data problem. RAID 10 is the combination of 1 and 0. So not only do you have 2 drives that will stripe, that we can use across, but 2 other drives will be used for mirroring. When it comes to backups, there are different types. We have the full backup, which copies the entire device or storage system. These can get costly because it's an entire backup. There is the incremental. They capture the changes since the last backup. It's faster to create these backups, but it's slower to recover. A differential captures changes since the last full backup and is faster to recover, but is slower to back up. So incrementals are slower to recover, faster to back up. Differentials, faster to recover, slower to back up. Snapshots are typically used in virtual machines. They create a full system state, and you're able to revert to that system state. There's also images, which are similar to snapshots and are a complete copy of a system down to the bit level. Your backup media is important. The decision on what backup media to use depends on your capacity, your reliability, the speed that you want it to run, the cost, expected lifespan, and how often it can be reused before wearing out. Tapes are the cheapest and have the highest capacity. Tapes are great for long-term storage. You can record terabytes of data very cheaply on tapes and store them in a closet, and it'll retain the data for a very long period of time. To recover, it is going to be slow because it's a tape after all, but it is your cheapest option who will give you the most bang for your buck. Tapes are also great against ransomware. Because it's a tape and you have to physically eject it, it is no longer connected or mounted to the drive. If and when a ransomware attack happens, well, you can just put the tape back in, restart, and pull back from the tape, or restore from the tape, I mean. Ransomware gone. You still should find out how the ransomware got in the first place and fix that vulnerability, but tapes are a great asset. Your disks, either magnetic or solid state, are more expensive than tape. They are faster than tape. You can put them in large arrays like the RAID arrays that I mentioned earlier. You can put them in network attached storage or storage area networks. Optical media like Blu-rays and DVDs are not as common to use as a large-scale backup tool, mostly because they tend to be a write once. So while they could work as like the tape does, the problem is with the tape, you can rewrite later. With Blu-ray DVDs, not so much. There's also flash media, which could be short-term copies or longer-term backups. Another decision that you need to have is whether your backups will be online, which means they're always available, or offline, like tapes, where you have to retrieve them from a storage location. Offline backups are used to ensure an organization cannot have a total data loss. There's also something called the nearline, not immediately available, but can be retrieved within a reasonable period of time without a human involved. Cloud providers have lower prices for slower access times and provide what is essentially offline storage with a nearline access model. So when you think about backups, always think about the bandwidth requirement for the backup and restoration, the time to retrieve files and the cost of file retrieval, how reliable they are, and any new security models for backups. Response controls are used to allow organizations to respond to an issue, like an outage, a compromise, or a disaster. Recovery controls and techniques focus on returning to normal operations. Non-persistence is the ability to have systems or services that are spun up and shut down as needed, reverting to a known state or a last known good configuration. Scalability is a common and useful response for high availability systems. The two major categories are vertical, which are expensive. They require larger or more powerful systems or devices to help all tasks or functions. And there's also the horizontal, where we add more systems and can grow and shrink as needed. Both serve various purposes. Horizontal supports scaling with software-defined services, whereas vertical can help during a natural or a human disaster or equipment failures. Site resiliency is a critical design with three major types: the hot site, the warm site, and cold. A hot site has all infrastructure and data and ensures that staff are in place in case of an emergency. A warm site has some or all of the systems needed to continue to work, but live data is not there. And a cold site has space, power, network, but is not prepared with systems or data. Restoration order must always be considered in order of criticality of the system. So a restoration order could be, we need to restore first network connectivity and a shell host. Then we need to restore our network security devices like our firewall, our IPS. Then we need to enable our storage and database services. Then any critical operational servers, logging and monitoring, and then other services. This all depends on what on your infrastructure. That is not a list of that applies everywhere. So you have to, with your organization, define when a disaster happens, what is the order of things that we need to restore, in what order, in order to get back to work. I know I use order 3 times in that sentence, but you have to figure out what's first, what's essential, and work your way down until everything is back online. When it comes to physical security, one way is industrial camouflage. Having the business or having the network infrastructure, like the data center, be in a nondescript location that is largely unmarked or otherwise innocuous. Fences are your first line of defense as a deterrent. They could have barbed or razor wire and other parts to increase security. Bollards are posts or other obstacles that prevent any vehicle from moving through an area, like from the street into the building. Plenty of lights prevent any area from being shadowed or too dark and can be used to discourage any intruders. Having badges for all staff is another way to identify who has the authority, the authorization to walk in to a room or a building. Having alarms to detect and alert about any issues like unauthorized access, environmental problems, fires. These can be remotely monitored or locally monitored, depending on the complexity and the capability. A good note is any alarm that goes off too often or has a great frequency are likely to be ignored, disabled, or worked around by staff. So when you have an alarm, make sure you tune it well. We can't forget fire suppression. A wet sprinkler system will have water. A dry sprinkler, which is empty until needed. A pre-action sprinkler fills when a potential fire is detected. Deluge sprinklers start empty but are activated and cover an entire area. Signage, even though it seems kind of silly, signage is important. It reminds authorized personnel that they're in a secured area, and non-authorized people should not be permitted to enter. It also helps in the court in a case that someone could say, oh, I didn't know. There wasn't signage that told me I could not walk into X, Y, and Z. Man traps ensure authorized individuals gain access to secure areas and attackers can't piggyback. Some banks and other secure facilities have these man traps. If somebody's trying to get in who's not authorized, well, they're stuck. If somebody is stealing something, they could get stuck right in there. A common form of security control are cameras and sensors. They allow observation in real time and capture footage. Motion recognition cameras are useful when motion is infrequent. They'll have a buffer that will be retrieved when motion is recognized, so they'll retain a few seconds before the motion started. These type of cameras can conserve storage space. Object detection cameras detect specific objects or have areas that they watch for changes. Closed circuit television display what the camera is seeing on a screen. And you can have all kinds of sensors like motion, noise, moisture, temperature that can all be used for security and environmental controls. There are also guards. Now, security guards are used in areas where human interaction is necessary or helpful. Guards can make decisions that technical security controls cannot, providing additional capabilities by offering both a detection and a response. Visitor logs are a common control with security guards, as they can verify an individual's identity, ensure that specific person enters the area as they are supposed to. Now, yes, guards are human, so they are fallible. Social engineering attempts could persuade them to violate policies or provide attackers with assistance. Organizations may have a specific need for greater security in certain spaces versus others, like data centers. Data centers can have hot or cold aisles that place air intakes or exhaust on altering aisles to ensure proper airflow. Administrative controls like two-person integrity. Control schemes can secure safes or vaults by having two staff members provide access with dual keys, passwords, or portions of an access control factor, like biometrics and key fob. Faraday cages can block electromagnetic fields. These are used in high security facilities to prevent any wireless communications from occurring, or are used in digital forensics investigations to prevent the device in question from connecting, like a cell phone that's been taken into custody. A demilitarized zone can be a logical or a physical segment of a network used to contain systems accessible to the outside world. Firewalls can limit the flow of traffic into a DMZ. Physical telecommunication lines are susceptible to attacks and require cable protection techniques like locks, secure cable conduits, tamper-evident seals, and so on. When network security is not sufficient, you can use what's called an air gap design, which physically separates network segments to prevent network connectivity. For example, with these two network switches, there is no cable connecting the two together. So any system connected to the top Linksys switch cannot communicate with the one under. This is an example of an air-gapped network. When data reaches the end of its lifespan, destroying the media that contains it is an important security measure. Physical destruction is the most secure way to ensure data is destroyed. You can use third-party solutions to send them physical drives, and they will send you back a document certifying that the drive or drives you gave them are defensively destroyed. You could do it yourself if you have the right tools or are creative in finding ways to destroy it. Chapter 10 covers cloud and virtualization, which is kind of funny to me that it's being covered in the 10th chapter, and we've been using the cloud since the second module. So not these type of clouds. The cloud service providers deliver computing resources to their customers over the internet. Many of the key benefits of the cloud derive from it having various qualities, such as on-demand, which is provision or deprovision almost immediately, over-subscription, where not everyone uses all their resources at the same time, multi-tenancy, many users share the resources in the same infrastructure, and a variety of configurable computing resources. Some of the benefits: it's on demand. It's available when you need it. It's scalable. You can increase the capacity or decrease as needed, and you can do it vertically, where you add capacity to an existing server, or you do it horizontally, where you add more servers to a pool. It's elastic. The capacity can expand and contract as needed to optimize your cost. Everything's measured. Everything you do is measured by the provider, and you pay exactly for what you use. And it's agile and flexible. It has a speed to provision resources and be used for a short time. There are roles that you should be familiar with. There is the service provider. These are firms that offer cloud computing services. They may build their own data centers or work hand in hand with other providers to deliver their service. There's you, the consumer. Organizations and individuals who purchase cloud service from providers. There are the partners, or otherwise known as a broker. They offer ancillary products or services that support and integrate with offerings from a provider, for example, training, consulting, software development. There's also the carriers, the intermediaries that connect you to the service provider. There are many different cloud service models. 4 of them show up in the Security Plus exam. That is the Infrastructure as a Service, or IaaS, down here at the bottom. allows customers to purchase and interact with basic building blocks of infrastructure, like computing, storage, and network. The customer does not worry about the underlying hardware and physical facility. And hey, look, Google Compute Engine is right here. That's what you're using in this class, the infrastructure as a service. On the polar end is software as a service, provides customers with access to fully managed applications running in the cloud. The provider is responsible for everything from the operation of physical data centers to the performance management of the application itself. The customer is responsible for limited configuration of the application, the selection of what data they wish to use with the cloud solution, and use of application provided access controls. So things like Slack, things like G Suite, things like Discord are all software as a service. You don't know what infrastructure they're running on. You don't care about how much RAM is being occupied on what server, what type of server. You don't care about the speed. You don't care about any of that. You're just accessing the data itself. There is platform as a service, kind of in the middle. A provider offers a platform where customers may run applications they have developed themselves. The provider builds and manages the infrastructure and offers customer and execution environment like code libraries, services, and tools. And there's also function as a service. Allows customers to upload their own code functions to a provider, and the provider will execute those functions on a scheduled basis, like in response to an event or a demand. Function as a service is also referred to as serverless computing. The 4 types of cloud deployments that you deal with are these. A public cloud is accessible to any customer in a multi-tenant model. A single customer may be running workloads on servers that are spread out throughout one or more data centers, with those servers running workloads for other customers simultaneously. The private cloud is any infrastructure that is provisioned by use by a single customer. It can be built and managed by the organization using the infrastructure, or built, managed by a third party. There is the community. Services run a multi-tenant environment, but tenants are limited to members of a specifically designed community based on shared mission, similar security and compliance requirements, or other commonalities. The hybrid is a catch-all term. It's a blend of these different clouds together. A public cloud can be something like Google Cloud, where yes, you are running a virtual machine, but you don't know what server it's actually running on and how many other VMs of other customers are being ran in that same server. A private cloud could be something that you run yourself. A community cloud could be like the Bay Area's NetLab, where all 28 community colleges access this one data center to do things. And a hybrid is just a mix of these, depending on the setting. No matter where our systems are hosted, we must think about the CIA triad and implement strong access controls and other mechanisms. Cloud security operations differ from on-premise because cloud customers must divide responsibilities between one or more providers. In platform as a service, a vendor takes responsibility for the operating system, whereas the customer retains responsibility for the data being placed in the environment and configuring security. In software as a service, the provider takes on almost all security responsibility, and the customer retains some shared control over the data. There are a number of cloud standards and guidelines, like the Cloud Reference Architecture that's published in NIST SP 500-292, and the Cloud Security Alliance, an organization made by industry that develops and promotes best practices in cloud security with what they call the Cloud Control Matrix. A fundamental technology of cloud is virtualization. Virtualization allows multiple guest systems to share the same underlying hardware. The virtual host runs on a special operating system known as a hypervisor that mediates access to the underlying hardware. Hypervisors enforce isolation between virtual machines, so each virtual machine has its own separate physical dedicated environment. Isolation ensures that virtual machines don't interfere with each other. There are two types of hypervisors. There is the bare metal, which operates directly on top of underlying hardware, and the application, where it runs on top of an existing operating system. Things like ESXi from VMware is an example of a type 1, where you install ESXi on a piece of hardware, and then you can run virtual machines there. Type 2 example is like VMware Fusion, Workstation, and VirtualBox. You have to have an operating system like Windows or Mac or Linux, install that application, VMware or VirtualBox, and then you can create virtual machines. Regardless, we have virtualized servers. We also have containers, which provide a really small application level virtualization that doesn't require an operating system. Containers package applications and allow them to be treated as portable units of virtualization. The interface becomes consistent regardless of the underlying OS or hardware, while sharing similar security considerations with virtual machines. When it comes to cloud storage resources, we have block, file, and object, where in block we can allocate large volumes formatted by virtual disks and by operating systems to be used as a physical drive, or like a physical drive. You also have object at the other end that puts files into buckets and treats each file as an independent entity that may be accessed over the web or through an API. When working with cloud storage, keep in mind to set permissions properly regarding the object storage. A few clicks can inadvertently publish a sensitive file. Consider high availability and durability options. And also use encryption to protect sensitive data. Either apply your own full disk encryption or use one provided by your service provider. Cloud networking. There are different terms that different providers use, but they're basically the same, of having security groups that are network traffic rules. This is the same as a firewall rule set. You have the virtual private cloud, which is the equivalent of a VLAN, as long as like in Google, as long as the VMs are in the same region and zone, they're able to talk to each other using internal addresses and don't require a connection to the outside world. There's also DevOps and cloud automation, where DevOps bring together the development and operation streams in a unified process where they work together in software development. This is where software testing becomes automated and collaborative. We basically use code to provision, maintain, and deprovision infrastructure as needed without human interaction. Here's an example of cloud automation. We want a Amazon EC2 instance. We want it to have this security group. We want it 2 volumes. One side is 50 gigs, another one 100 gigs. So rather than selecting like you do in Google, where you're going through options in that wizard, you just run a piece of code like this, and it will create that VM. Lastly, we have cloud security controls, or issues and controls. Starting with the issues, the availability. Cloud providers operate in different geographic regions, and they have mechanisms for backing up data across the regions or operate in a high availability mode across zones. There's data sovereignty, something that you have to think about when you go high availability. The principle that data is subject to the legal restriction of any jurisdiction where it is collected, stored, or processed. Some providers offer explicit control over the use of resources in specific regions. This comes into play if you're working with Europe. Under GDPR, data that is made and stored in Europe stays in Europe. Something that you have to think about if you want to use a data center on that part of the world. There's virtualization security. There is a very real threat that a piece of malware can escape the virtual machine and access the service provider's resources. The other virtualization security issue is VM sprawl. When users create virtual services or instances and forget or abandon them, and they keep accruing costs, but nobody's using them. Application security, ensuring that the APIs are secured, that there are secure coding practices, utilizing web gateways. And there's also the governance and auditing, ensuring that organizations are consistent with any organizational strategy and policy, along with any regulations that they need to follow. Some controls that you have are security brokers, software tools that serve as intermediaries between users and providers. They can work inline, physically or logically, through hardware appliances or endpoint agents. The inline advantage is being able to see the request and allow or deny before it reaches the cloud. API-based security brokers do not interact directly with the user, but work directly with the provider's API. Resource policies can be used to limit the actions that users can take. So we can deny things, we can allow certain things. And of course, secret management. Having hardware security modules that manage encryption and perform cryptographic operations. They can create and manage encryption keys without exposing them to a human, minimizing the risk of any key getting compromised. This week, you will complete, well, this week you will start. You don't have to complete it in a week, but you can if you want. The Complete Beginner Learning Path in TryHackMe. There is a certificate you get at the end, and you complete all the rooms. That is what you're submitting. I don't expect you to complete this in 1 week, but you are expected to complete it before the semester ends. Also, while you are working on the Complete Beginner, research GCP, AWS, Azure, and DigitalOcean. Answer these 4 questions. Again, I don't expect a 20-page paper in answering these questions. I do expect some thought be put into it, so I'm not looking for a 1-sentence answer to each. Give it some thought, but I'm also not expecting a 20-page paper. So complete the beginner track on TryHackMe and answer these 4 questions in regards to these 4 cloud providers. Please remember that next week is spring break, so there will be no streaming. But if you have any questions, as usual, use the text channel on Discord and the AllSec Plus to ask questions.